Hello, grade 11. This video is on vectors and how to find the components of the vectors. So let's take vector A, let's say. If vector A has, it is parallel. If you compare to the x-axis, this here is the y-axis and the x-axis. If you compare vector A to the x-axis, it is parallel, so we say that it's along the x-axis. And if you see here, the components of these vectors is only ax. What do you mean by ax? It means that it has a component, or this part is just in the x-axis. It has no component along the y. Okay, if you can see, the component in the y for the a vector is 0. Why is that? Because it is parallel to the x-axis, or it's along the x-axis, right? Now, if a, let's say, is along the y-axis, or if it's parallel to the y-axis, okay, like in this example here, okay, it has only one component, that is AY, and it has no component along the x direction, okay? However, let me now start with vectors in a plane. If we have a vector in a plane, and you can't know if it's along y-axis or if it's along x-axis, this means that this vector has two parts. It is made, or it consists of two parts, one in the x direction and one in the y direction. So when you see a vector in a plane, like this example here, it means it has two components, one in the x and one in the y. So how can we find these two components? What you do is that when you want to find the x component, or the part of A along the x direction, you project a line from the head of A that is perpendicular to the x-axis. Let's see how. Okay, like in this video, I will show you. So you project a line, this dashed line, along the x-axis, and you will find the ax, okay? The component of A along the x-axis. So this dashed blue line here is ax. It's the component of A vector along the x-axis, okay? Okay, now if you want to find the y component of A, the y component, what should you do? You project a line. You project a line that is perpendicular to the y-axis, okay? Okay, from the head of A, you project a line to the y-axis, and this here is the y component, or ay of this vector, okay? So let me show you this final triangle here. So this is the A vector, this is the AY, the component along the y direction, and here it's the AX, the component of A along the x-axis. We notice that the angle here between the two components is what? It is 90, right? So this here is a right triangle. We call it a right triangle, okay? So in this figure here, I will teach you two rules. There are two rules actually that help you to find the components of this vector. So any vector that is in the plane xy has, as we said, two components, and to find these two components, we use these two rules, cosine theta and sine theta. Of course, must know that this is a right triangle. Okay, so these two rules are in a right triangle. This is the A vector that we spoke about. Okay, this is the AX vector, and this is the AY. Cosine theta, this is the angle theta here. If for example, theta was here, cosine theta is adjacent over hypotenuse. What do you mean by adjacent? What do we mean by hypotenuse? Adjacent, it's the side that is adjacent or next to angle theta. It is the side that is next to angle theta. Okay? In this case, it's what? It's the AX, right? So cosine theta is AX. Okay, what is the hypotenuse in this triangle? The hypotenuse side, it is the side that is facing or the side that is opposite to the angle 90. So in this case, it's A. Okay? Okay. Now, sine theta. Sine theta, it's the opposite side over the hypotenuse. What do you mean by opposite sides? It's the opposite side to angle theta. So angle theta is here. The opposite side is the side facing the angle theta, which is what? Which is this side. And this side is what? It's AY. Right? So sine theta is equal to AY, which is the opposite side, over the hypotenuse, which is A. So these two rules help us find the components, and in the next video we will do an exercise to better understand how we can use these two rules, okay? And this one here.